Hi everyone. So let's begin. But before we do so, last minute adjustments. So seems the topic I will be talking about is more popular than I thought. And just during this conference I learned about 2 new projects that aim to solve this particular problem of workflows. So those 2 are not accounted for in my presentation, but they look great. And I'm very happy to see them coming. So before we go to the actual content, let's do a little bit of expectations management. So this presentation is not a tutorial, so you will not learn how to build stuff. It's not a deep dive, so you will not learn how the stuff works, and it's definitely not Scala heavy. So I was solving this particular problem from Scala, so I'm speaking from Scala perspective, but we will not be focusing on this particular aspect heavily. What this presentation is, it is a problem introduction, so I will try to define the problem of workflows and some particular aspects of it that I think are most important. And then I will do a quite shallow comparison of 3 different solutions to that particular problem with good and bad things about each of them. So this we can skip, and let's start with problem definition. So what is a workflow? This word is quite ambiguous, so let's maybe start with a couple of synonyms that can be used as a synonym in different contexts. So it can be called long-running process, business process, persistent state machine, service orchestration, process orchestration. All of that sometimes mean exactly the same thing, which is a series of steps with some internal state that has to survive a system restart. So that's basically the shortest definition I was able to come up with. A little bit longer definition is that a workflow is a process that spans from few seconds to few weeks. This is what long running means. It involves waiting for something. For example, human action or asynchronous response or something like that. And it has some state kept between the steps. Okay? So I have a couple of examples here, so we can build an intuition and maybe connect it with what you were implementing. So for example, a very first example, a shopping cart, right? So you have a flow, user goes through particular steps. Let's take a payment, right? You have to wait for the payment to be processed to follow the process, so this is waiting. But in case your system dies after the payment, you don't want to reinitiate it. Like, you need to store the information that the payment was done, right? Alternative scenario, you make a withdrawal from a bank, from a fintech. So there are some checks happening, like anti-money laundering or whatever, before this is actually the money is sent away, and then you wait for someone, maybe, to manually approve the transaction, right? So this is also waiting. And here is another example, a little bit more technical. So you can also think of installing software in a big corporation on hundreds of machines, and like here the software you're installing, the installer is not very reliable. So you might need to raise the problem to IT support, they need to fix it, and then you ensure that the software was installed. So now we know what is the workflow. Now a little bit of why I am talking about this. So for the last 4 or even 5 years now, I've been working with this kind of problems on a couple of different projects in 2 different companies, and in the end I think I worked on more than 20 different workflows at the time, and I used a couple of different solutions. So a little bit on that. So I started doing security automation at Sony. So there was a security department, like hundreds of people, engineers, but not Scala, not developers. They had some work to be done. They wanted it automated, so we were the automation team there. We had a lot of requests, a lot of stuff to do. So we tried to find a way to automate those processes as quickly as possible. So this is why we experimented with low-code approach. This will be Kamunda that you will see in a second. On top of that, we thought that, okay, we have engineers, maybe we can expose a platform so they can automate their work themselves. We will just provide utilities to do that. And it was not the greatest idea, at least not with Kamunda. And then I moved to Swissborg, and right now I'm responsible for financial transactions, which are really like long-running stateful processes. So for this talk, I tried to identify the most important things, the most important challenges of workflows, and I identified 4 of them. It's versioning, overview, introspection, recovery. We'll go through each of them right now. So the versioning is the term I use to describe what happens to the process that is already running when you define a new process, the new version of it. Like you modify the flow, you add additional branch, you remove a step, add a step, all of that stuff happens, and then what do you do with that? The next thing is overview. So this is probably the biggest problem I'm dealing right now, is to be able to see as a visual my flow. Because if it's code, it very often leads to the situation when no one really knows what it does. And yeah, it's maintainable because it's like compiled, Scala, type safe, we do whatever we can. But in the end, you can't really describe it end to end with all the details just by reading the code. So this is I think the biggest challenge, which I called overview. Next thing is introspection. So you have a process instance, like particular transaction, particular by order, particular software installation, right? A single instance of a workflow, and you need to know what happened to it. Like what steps were taken, which path it went through. So this I call introspection. And then the last one is like, the technical one is how do you recover to the last state after the system restart. So let's say you have a data center failure or whatever, you need to recover the state you had before. And now about the solutions to this problem and these 4 challenges. But before we begin, I would like to ask you, really, don't do it to yourself. Like, I will describe a couple of things, but I don't recommend using any of them if you don't have a strong need. Like, if you see a way to do this without those tools, it will probably keep you, like, save you a lot of work at the beginning, at least, because those tools are justified only if you have a certain scale and like certain amount of workflows or complexity of those. But let's assume you really have to solve that problem with external tools. So, or like semi-external. I will talk about Camunda, which is a BPMN engine. I will talk about Temporal, which we already see just half an hour ago in the Vitalis talk. And in the end, I will briefly talk about raw event sourcing. This is something I'm using right now. So maybe a little disclaimer, I used Camunda Temporal like 2 years ago. So I tried to refresh my knowledge, but yeah, you might probably know more about it than I do. And now, what to expect from this part? I will tell you how it works, how it doesn't, and how it solves those 4 challenges that we identified. So first is Camunda, and let's see how it works. The first thing you need to do when you start working with Camunda is to pick between versions 7 and 8. This is something that changed in those 2 years. I think they changed a distribution model right now. When I worked with it, it was very open source. You just spin Docker up and it works. Right now, I think they are moving more into SaaS way of doing things. I'm not entirely sure, but it's like, I think there are some differences here. Then you define your workflow. The workflow in Camunda is defined as an XML file, and you have a couple of ways to do this. In the end, you need to define the XML file, right? So the first way is to use the graphical editor. So Camunda ships with this, this kind of drag boxes around kind of thingy. And alternative to that is the DSL. They also give it, like the Java DSL, that you can use to programmatically build a workflow. The next step, once you have the workflow, you have to integrate it with the backend. Like, I'm assuming your steps will be executed by external services. So not inside Camunda, but you have a service, it has some sort of an API, and you just, or not even the API, you just have a dedicated service to do the steps. In this case, how Camunda works with service tasks is that your service polls Camunda server for tasks. It logs one of them, do the work, returns the response. So this is the model. Then this is how you connect the service tasks with your service. Like this maybe is not doesn't give you the full picture, but basically you need to type here some free text field that is called type here, and it's like task identifier, and then also free text stuff, like very dynamic with the variables being involved in these particular tasks. So you have like what you expect on your service side might be very different from the workflow definition, like because it's all just random strings representing variables. But we'll talk about this in a second. Once you have your workflow, it's connected to your backend. Now you deploy this to Camunda server. So you just need to push XML there. Like there is some UI in the modeler we have seen. You can use the API endpoint. It's just this. This we can skip, but I think architecture changed a little bit in this new version. Okay, so how does Camunda solve the main challenges? First, versioning. And here I think it's done pretty well because it solves it in 2 ways. Like first, all the flows that were started will run on the version of the workflow that they were started with. So Camunda keeps history of all the workflows, all the different versions of it, and just runs existing instances of the original version. That's the minimum, absolute minimum that you need to have to conveniently work with it. And then the second problem is migration. So maybe you want to move your existing instances to the new version of the problem, and here Camunda also supports this. It has a quite rich dedicated API to move instances from one workflow version to another. Then the overview, like the XML files are renderable both locally and on the server side. So we can browse all the workflows in all versions and just see what are the steps involved. Then introspection, here Camunda does even more than I think is good, because it allows you to not only see all the variables in all of the steps from process history, workflow history, but it also allows you to modify the workflow state, like dynamically in runtime with whatever you want. You can drop variables, add variables, change them, like just from the UI. So it's very powerful, probably more than you want. So this is how the server UI looks like. This, I'm not sure how well you can see, but it marks the path that workflows took. So this is a view of one particular instance. There are steps taken here, I believe. Yeah, And then recovery is just a black box, it just works. So we don't need to spend time on it. So now problems with Kamunda. The workflows are very, very dynamic. So it's really easy to create something that is not correct. And to mitigate that, we build a linter. So something that takes an XML, parse it, like parsing is easy because there is Java DSL to do that, but then we run on top of it a linter that detects potential problems. Then you don't want to use the graphical editor. Like really, really, really you don't want to do this. Like we tried, and from I think 5 people team, 3 wanted to quit just because we had to modify this stuff in the graphical editor. And to mitigate that, we created a DSL in Scala to build the workflows programmatically. But this is another thing you need to do. Then the third thing is that the workflows are fragile. Even if your workflow is semantically valid, it might still not do what you want it to do, so you need to test it. So there is some testing SDK provided by Kamunda based on JUnit, but you need to tailor it to Scala, so this is another thing you need to build to work with Kamunda efficiently. Then the workflows have the mutable and dynamic state. As I said, you have variables that are just strings that can be removed, added, like in the workflow definition. So to mitigate that, we wanted to connect our DSL for building workflow definitions with the infrastructure of handling the tasks on the backend. So we can have a single task contract, like input and output, and then reuse, for example, case classes in both the workflow definition and the backend. And this required even more quite crazy work to make it happen. So this is yet another thing you need to build. So the bottom line here is, I think Kamunda is quite a good project. Like, I think it solves the problems pretty well, but it's so powerful and so dynamic that you need to build a lot of stuff to constrain it and make it comfortable to use from Scala. So if you have, like, I don't know, 2,000 developers and hundreds of workflows, then it's probably worth building custom tooling around it and using it to solve the problem. Okay, so now let's go to Temporal. In Temporal, okay, maybe a question. Who have seen the previous talk about Temporal? Okay, like 2/3 of an audience, so I will do this quickly. You have seen it in much more depth then, but a quick recap. So you first need to define your activities. So the activities are interface plus implementation. In this case, you have a trait, and you have the implementation. It's not like with Z or Temporal, it's probably a bit different, like maybe more convenient, but basically this is what you need to do. Then you define your workflow, and the workflow is a series of either in-process deterministic computations. So this is very important. Everything that happens inside the workflow needs to be deterministic. And then whatever is not deterministic, it goes to activities. And in this case, the workflow has input, output, and then some implementation. Sorry for the indentation, it broke for some reason. But basically, you create a stub of your activities. So basically an instance of the interface, but that will go through network to actually invoke them. We'll talk about this in a second. And then you implement the workflow just by doing either deterministic stuff, like this is deterministic, always yields the same result, or you call an activity. And then you need to run your servers. So in the end, you need kind of 3 servers, even if it could be 2 in practice. You need a temporal server, which is just something that Temporal ships. And then you need something that will run the workflow code and the activities code. This can be a single machine, single process, multiple instances, doesn't really matter. And then let's see how it works in practice. So when you make a call from workflow to activity, a temporal intercepts the call. It sits in the middle between those two servers. So even if it's like single process, it still do a network jump. It intercepts the call. It detects if it's a first execution of this particular task or is it a recovery. Then if it's a first one, it just passes the request to the activity server. But if it's a replay or a recovery, it just gives you the previously cached response. So whenever you need to reinstantiate your process, like for example, machine died, or you had to wait for a long time, so the process was killed, then it just started from the beginning, and all the calls to activities that were previously executed just get the previous response. As you may imagine, it produces some problems. So the first challenge, versioning. So the new version of the workflow must behave exactly the same for the old workflow instance, meaning new definition, new code for the workflow will be executed for the old instances because it's not stored anywhere. And because it has to behave exactly the same, all the steps need to have same input, same output, run in the same order, you need to put if statements, conditionals, in the logic to just keep this backward compatibility. This is, in my experience, very inconvenient and one of the biggest problems with Temporal. So just to, you can imagine this is the idea. You just get the current version and do the conditional what needs to happen just to keep the backward compatibility. Then the overview, no, there is nothing because Temporal is imperative. So if you can decide about branches based on the outputs of previous tasks, you cannot draw this. And yeah, there is no diagram. You would need to build a declarative something on top of it to have the diagram. Then introspection, yeah, it's there. Like there is a UI with the server, you can see all the tasks being executed, all the stuff, so this is good. Then the recovery, it's also kind of a black box, but in the end it's even sourced. Yeah, and then it works as we described. So problems. Java SDK is Java-ish, so it's hard to work with. Now we can do better. We have Zero Temporal, which probably solves a lot of problems for you. I remember the biggest one being serialization, like it was quite hard to get it correctly. There are no migrations, so the versioning problem, as we decided, like you need to figure it out. At least maybe they changed something, but that was the case before. No overview because it's imperative, and the bottom line, it's much better for the developer experience, for creating the workflows, but it's not as rich in terms of maintenance, like operational work, as Kamunda. So yeah. This is it. And then custom event sourcing. So this is something I'm doing right now. It can be used to solve the same problem. So the first step when you want to do event sourcing is you pick the library, and this is the first problem you face because there is no good choice right now. Like you have Akka, which is changed the license recently, and its fork is not yet, I think, released properly. And there is there's Ecor, Endless4S, but I don't think they got any traction, or you build something yourself. Then what we do is we express workflow as a set of commands and events. So external world sends commands, they transform to events, events modify the state and can produce more commands. And events are persisted in the journal. And whenever you need to recover the state, you read all the events and go from there. So the main challenges here is the versioning. You need to keep backward compatibility of the events. So you have a couple of solutions here. So you either make everything backward compatible, or you migrate the journal, meaning in the database change one thing to another. or you snapshot the state. So basically, you fold all the events to some state, and that's a snapshot. So yeah, then overview. There's nothing, and this is something I've been working on for the last 2 months to build a declarative DSL for our event sourcing infrastructure to be able to draw a diagram, because we reached the point when it actually will pay off. And maybe next year I will have a follow-up presentation about that. Introspection, yes and no. You have the events, and only the events can modify the state, so you have quite a good way to introspect, but a crude one. So you can build on top of that, and yeah, but you have to build it. And then recovery, as I mentioned, the state is rebuilt from events. The process is always continues from the last recorded event. So that's really it. So I ask you to not do it to yourself. So is there another way? Obviously, there is ZeoFlow right now. So that's another way. But despite that, if you don't feel like you have this problem in a big scale, you can just take it simple. Like, put your state in a database, implement the operations in a totally idempotent way, put recoveries on top, like retries on top, and that's it. If you need traceability, you can do poor man event sourcing, which is append-only database table. So whenever you modify the state, you put a new entry in the database. Like, it will be much simpler, probably easier to build. My time is off. So yeah, a summary. Yeah, Kamunda requires a lot of tooling around to be productive. Temporal is much better to work with, but also at the cost. Raw event sourcing is most flexible, but it's probably even more work than Kamunda, or comparable at least. And nice thing is that both Temporal and Kamunda developed a lot in those 2 years. So I checked the state right now, and I remember what was then, and both those projects move forward. So they're not dead, they're actively maintained, there are companies behind, which is really nice for picking, judging a solution. So thank you. You can find the slides there, you can also leave some feedback there, you can find me on Twitter, and you can ask me questions on the corridor or like on Discord. No, I'm probably not on Discord, so you need to find me here. Thanks a lot.
Thank you so much.